Hey everybody, welcome back to Proving Identities with Mr. Longo. And we already had a video on Proving Identities Part 1, and what you did with that are some easy ones. Now what I want to do for this video is let you try to do some of it on your own. Now this first one I'll tell you is only going to be about a 3-step proof. The easiest way to do this one would be to make that big thing on the left turn into the little guy on the right. So to do that, I will tell you your first step. Now your first step should be to factor out the greatest common factor of secant theta from the left side. And then see where you can go with that. So pause the video, give number 1 a try. As soon as you're ready, click play, and we'll see how you did. Like I said, your first step should have been to factor out a secant theta from both sides, and that would leave you with tangent squared theta plus 1, and that's still equal to secant cubed theta. And tangent squared theta plus 1 is one of your Pythagorean identities. So tangent squared theta plus 1 is actually equal to secant squared theta. So you have secant theta times secant squared theta, and obviously if you multiply secant times secant squared, you will end up with secant cubed theta. So like I said, it's a pretty easy one. All you had to do is factor out the secant, and then of course use Pythagorean identities. So first one, again, pretty simple. Hopefully you got that right. Let's move on to number 2. Number 2, this one is also only going to be about a 3-stepper, and the hint for this one is to use the Pythagorean identity with cotangent squared x on the top of the fraction on the left side. If you do that, you should easily be able to get cosecant x minus sine x. So why don't you go give that guy a try, and we'll see how you do. So again, cotangent squared x is equal to cosecant squared x minus 1, and that's all over cosecant x. And we always have to set it equal to the guy on the right. Now, one thing that you are allowed to do is split fractions when the plus or minus is in the numerator. You can never do that when the plus or minus is in the denominator, but remember, adding fractions needs to have a common denominator. So our denominator is cosecant x. So we can simplify this to cosecant squared x over cosecant x minus 1 over cosecant x. And you can see it's only going to be one more step before we have cosecant x minus sine x, because we have 2 cosecants on top, 1 cosecant on the bottom. So that's going to cancel that, and you're going to have cosecant x minus, and we know that cosecant is a reciprocal of sine, so we have sine x, and we're done. So there is another way that you could have gotten fancy, and you could have turned these into fractions and then subtracted them, but again, getting this to look like that is going to be the easier approach to it. But if you want to pick the right and work to the left, that's fine too. Number 3. This is an example where you're going to need to multiply by a clever form of 1. So remember, I'll just give you a little thought. 2 divided by 2 is 1. X divided by x is 1. Cosecant divided by cosecant is 1. So you're going to want to multiply the left side by a clever form of 1. And I'll also give you one more hint. The conjugate. So if you remember what a conjugate is, I would multiply the top and bottom of the left side by the conjugate, because that would be a clever form of 1, and something cool will happen in the denominator. Okay? So again, why don't you pause the video, give it a shot, click play when you're ready. the clever form of 1 is we should multiply the top and bottom by 1 plus cosine x. That would be the clever form of 1 to multiply the left side by. If we do that, we will have sine x times 1 plus cosine x all over 1 plus cosine x and 1 minus cosine x. And of course, that's equal to our right side. 1 plus cosine x over sine x. And what we can do on the top is distribute. So we can distribute sine to both. But I'm going to say leave it out. Only because I know what's going to happen. But what you do want to do is multiply the bottom. Now, if you would have distributed that to the top, you would have been okay. You would have just have to factor it out later. But if you FOIL the denominator, you will end up with a Pythagorean identity. So like I said, I'm going to leave it outside just because I know what's going to happen. But if you would have distributed it, you would have been fine. You would have seen that you just factor it out and things are going to cancel. So 1 times 1 is 1. And then, of course, 1 times the negative cosine and cosine times 1 will cancel each other out. And then cosine x times a negative cosine x is a negative cosine squared x. That's going to leave us with 1 plus cosine x over sine x after 2 more steps. Because here, we actually have a Pythagorean identity. 1 minus cosine squared x would be equal to sine x. So, or sine squared x. So that's going to leave us with sine x times 1 plus cosine x all over sine squared x. And that's equal to our 1 plus cosine x over sine x. I'm sure you already know what the last step is. This sine squared is going to cancel that sine, and you are good to go on this problem. So we have simplified it all the way to 1 plus cosine x over sine x. So again, if you would have distributed the sine x into that, like it looks like you would have since you had to FOIL the denominator, you'd still get the same answer. It's just yours would have looked, you would have had one additional step because you would have had to factor it back out. So whatever works. The last one. Now, the last one could take you quite a few steps. I mean, I can see this one might take, 6 to 8 steps depending on what you do. It is a little bit of a challenging one. I will just straight up tell you the first thing you're going to need to do is find a common denominator on the left side and add those 2 fractions. And that's the part that could take you 1 or 2 steps depending on how much you can do in your head. So yeah, why don't you pause the video one last shot. This one is a little tricky, but if you get it, you should feel pretty good about yourselves after being able to do a problem this long after only 2 videos of proving trig identities. Click play when you're ready. Okay, common denominator. Your common denominator is going to be cosine x times 1 plus sine x. Remember, you can only multiply to get common denominators. You cannot just add something. So the right side is going to need the cosine x, and the left side is going to need another 1 plus sine x. Okay, so the first thing we're going to have is a common denominator of cosine x and 1 plus sine x. And that's going to be 1 plus sine x times 1 plus sine x. And then our separate term is going to be plus cosine x times cosine x, which we know is cosine squared x. Okay, and that's somehow all going to simplify to 2 secant x. So the next thing you're going to have to do is FOIL the top over here. And if we FOIL that, we're going to have 1 times 1 is 1. And then 1 times sine and 1 times sine is going to give us 2 sine x. And then, of course, sine x times sine x is going to give us our cosine, or sine squared x plus, and we already have our cosine squared x. That's equal to 2 secant x and the next thing you should notice is we have our sine squared x. It's a little sloppy. We have our sine squared x plus cosine squared x, which by now you should easily recognize is 1, one of our Pythagorean identities. So that's going to give you 1 plus 1 plus 2 sine x. So 1 plus 1, 2 plus 2 sine x all over cosine x times 1 plus sine x. And that's equal to 2 secant x. Now, here's one where you might have written out a separate step. Now, if you recognize that right away and you show me that that's a 1, I'm okay with it. But you also could have just done a 1 plus 2 sine x and then plus 1 on the end and then added one more step. I'm just trying to conserve a little bit of time and length to the problem, but really it's up to you. If you show me that you know this is 1, you can move from this step to that step. If you're not sure, then just do one step at a time. Okay? Now you should probably see where we're going after this. We have a common or a GCF of 2 in our numerator. So we can factor out a 2, and you're going to see something we already have in the denominator. You're going to be left with 1 plus sine x over cosine x times 1 plus sine x. And that should remind you about rational functions where if you have two things that are exactly the same in the top and bottom, they can cancel. So you're left with 2 over cosine x is equal to 2 secant x, and cosine x just jumps up to the top. So we have 2 secant x is equal to 2 secant x, and we're done. So again, I said this could take you like 6 steps. Now remember, I condensed this step, and I could have actually made you write 2 over cosine x. We could have, but I was trying to see how much of this problem I can fit on the screen for you at one time so you could see the flow of it. All right, so that's it for this video. Again, it was a little lengthy, but we are getting into some bigger proofs. Hopefully that helped you out. This is Longo, and I'm out. See you, bye.